Hello, my name is Elijah Davis, and today we're going to take a quick look at writing a Connector SDK solution with AI assistance, and specifically we're going to use Windsurf. Now, we're going to start in the Fivetran docs under the Connector SDK examples, and here we're going to see a link on how we can use AI to help us with the Connector SDK. So I'm going to follow this link, which brings me to the Fivetran public repo, where I have system instructions for AI. So I'm going to follow this, which brings me to an agents.md. So this is what I'm going to use as context and or a rule set in Windsurf for any contextual prompt where I wanted to build me a Connector SDK solution. Now, I also notice in this repo, we have a template example connector. So I'm going to take this connector.py as well and use it as an additional rule set so that in my prompt, I have all the context necessary from a Fivetran standpoint for the model to ideally write functional code in as few iterations as possible. Now, jumping back to the documentation, if we were to look at the setup guide, we have a few prerequisites. We need a Fivetran API key, we need Python, and we need an OS. So for your Fivetran API key, you simply go to Fivetran, click your name, click API key, generate one if you do not have one. Python is already installed. I'm using 3.10, and then I'm using macOS. And I also need a data source. So I'm going to use an API that is the openFDA API. And I'm specifically going to replicate data from the Tobacco API endpoint. And now, here we have a lot of context that would be really nice to add for our AI model to know about, so that when we give it the prompt, it can give us a highly contextually driven solution for our connector.py, config.json, etc. So going through this, we can see we got some authentication information about using an API key or not using an API key, what those limits are. We also have an overview of the general endpoint itself, as well as how to use that endpoint and example queries, which we can review the response data. All this is great context that we want the AI model to know about. So jumping over to Windsurf, we have a couple things. On the left-hand side is our project folder, which is FDA Tobacco Windsurf with fields.yaml and notes.txt. So notes.txt is everything that I took from the website that I deemed pertinent to this Connector SDK build, insofar as authentication, overview information, example queries, and response data sets. I also have a fields.yaml, which I took directly from the website as well under their searchable fields tab. I just grabbed the YAML. So now I have all that additional context, but I also mentioned rules files. So if I go over to Cascade, I have this customization option and rules. So in here we have our best practice, which is our agents.md file, and our template code, which is the connector.py template from the Fivetran Git repo. So I have my agents.md and my connector.py as rule sets in Windsurf Cascade. Jumping back, I can now construct a prompt. My prompt is going to have three main items. Item number one is the source data and what I want it to do with that source data. So I give it the endpoint. I'm asking it to incrementally upsert that data and track state through checkpoints by table. All in all, asking it to infer based on what it learns as it reviews these data elements. My second section is where I'm being a little bit more descriptive with what I want it to do, and also calling out specifics from my review of the documentation. And I also want to be logical with this because I'm just trying to test this out to see if I can connect to this API and replicate data. So for the initial build, I'm going to limit it to 10 responses to ensure that the API calls are not unnecessarily burned out. And I also want it to default to no API key being necessary. Again, we're strictly testing. We want to make sure we can get to the data source. We also want it to exit gracefully, leave clear comments, and define only the primary key. We're going to let Fivetran infer the rest of the data types. All values in the config.json must be strings. And our third section is going to be all of the context. So section 1 is data source. Section 2 is a little bit more specific of what we do with the data once we're connected. And section 3 is all of the context we want to drive this prompt with. So in this, we're saying follow those best practices that we outlined in our best practice rule set, which again is our agents.md from the documentation. We also have pertinent notes in notes.txt in our project folder. We have the data structure in our fields.yaml. We have template code in our rule set from the template that we took from the Git repo. And then we also are asking it to build the solution in our project folder. So ideally, this agent is going to review all of this context, generate a plan, and then execute it to create a connector.py, a configuration.json, and a requirements.txt. And ideally, we're going to do all of this with the SWE1, which is a free for a limited time model from Windsurf. So we're going to submit this prompt and let it create the plan and the project files. All right, it's going through, checking our notes, checking the fields.yaml. Now it's checking our best practices, and it's got a plan. Perfect. So let's check its plan. So its plan is it's going to draft the connector.py with schema and update methods. It's going to implement incremental sync logic, limit the API call to 10 records, define configuration.json with string only. It's going to create the requirements. It's going to add comments and logging. It'll prepare a README, and it's going to validate the connector with a DuckDB, which that's great. So it's now processing and building our connector.py. Great. It's now generated the connector.py. Here's our new file. It's now generated our requirements.txt, and it's about to start work on the configuration.json. All right, it's now creating the config.json. Here it is. So we're going to accept these changes to these new files. And last, it is building our README for this solution that it created. And here's our README. Looking good. It now wants to test the connector locally. Ideally, it's going to generate a Fivetran debug command for us. And if not, we're going to intervene and we're going to give it one. So it did not. And we will reject and ask it. So we're going to say, great, test the connector using Fivetran debug. And so this is a command that we're going to use. You can use it in the terminal as well. But again, we don't want to leave the chat. We want it to do it. So it's now generating a command so that we can execute and review if the connector was successful. Perfect. It's making sure we're in the project folder. Let's run it. And right away, it looks like we got 10 data records upserted, which is exactly what we wanted. We now need to check the DuckDB database to review that data. So let's give it the location of our warehouse DB, which, mind you, when you have a connector SDK and you're running it locally, inside your project folder, you'll get a files subfolder after your connector syncs successfully, which will have a state.json, where applicable, and a warehouse DB. And that warehouse DB will have all of the data that you replicated locally for your review. Typically, you would do this in dbeaver, but we're going to do it in terminal with AI to ask it to review that data. So we're going to give it the path. Can you show me the data in blank using DuckDB syntax? So here we're giving the model the direct path to our warehouse DB and asking if it can show us the data using DuckDB syntax. Here we go. It suggested a simple SQL query. Let's run the command, and there we have it. Inside the chat, we not only had it create the entire Connector SDK project for us with the connector.py, requirements, and config.json without even leaving the chat. We had it test the warehouse DB file and show us the data. So next, we're going to ask it to deploy it to Fivetran. All right, well, it wants to show us more. So let's take a look. Sweet. It's giving us the table structure. That's pretty cool. And what else does it want to do? It wants to give us all of the data. Now, it's going to check that off its list because it's created a plan. It wants us to validate this data and review it. So here we can see the tobacco problems and the health issues that have been noted relative to the data we were replicating from the data source. Once this plan concludes, we are going to deploy. Perfect. So, great. Let's deploy the connector using Fivetran deploy. Okay. And that was the incorrect command. So all we needed to do is to just execute the Fivetran deploy. So we're going to stop it there, and we're going to say deploy this solution using the command Fivetran deploy. And so as we see here, AI is amazing and fantastic. However, human intervention is still necessary, especially as we're taking these agentic approaches for complex tasks, such as, but not limited to, writing entire connector solutions. So it's good to always have context so that you can share it with the AI model so that it is able to learn from you and with you to make better solutions faster. And now here we go, it actually generated the command, and it's now asking me what destination do I want to deploy this to. So I'm going to jump over to Fivetran, and I want to deploy to CSG auto test. So I go back over to Windsurf, add that in. It wants a connection name. We're going to do FDA tobacco test. And our key was set as an environment variable before this demo. And so we are going to leave that as default. And then it's going to ask, does it need a configuration.json, which it does. So we're going to say yes. And it's now doing a default of my project folder, which configuration.json is in my project folder, so I can leave it as default. So I do not need to add anything. I will just hit enter. It's now going to upload my connector SDK solution to Fivetran and provide me a link so that I can go review this connector and kick off my sync. At this point, I now have a link, but I'll let it finish. There we have it. So now that the deployment was successful, all the while inside of the same chat, we're going to click the hyperlink inside of the terminal, which will lead us right to our FDA tobacco test connector, where we will trigger our initial sync. And so there you have it. All in all, what we have done is we went through the Fivetran documentation, grabbed publicly available information for AI system instructions. We configured our Windsurf IDE to use those system instructions. We then created a highly contextual prompt to give to the AI model so that it could create a Fivetran Connector SDK solution. Once it created that solution, we had the model debug the code locally to ensure the solution worked. We then, once the data was successfully replicated, asked the AI model to show us the data using DuckDB syntax, which it did successfully. At which point we had created a connector, tested the code, reviewed the landed data, and we were good to go test it inside of Fivetran and deploy it all without leaving the chat. At which point we went over to Fivetran and triggered our initial sync. All of this was done with the AI assistance of Windsurf and the system instructions made available in the Fivetran public Git repo under agents.md. I encourage you all to bookmark the AI and Connector SDK link as we are rapidly building out and iterating on AI solutions and the Connector SDK. I'm curious to hear about your new use cases and/or solutions built from the AI assistant system instructions, and I hope you found this session insightful. And if you have any questions or concerns, please reach out. I'm on the services team and here to help.